After completing this chapter, the learner will know the basic methods used for removing water and dirt from the fuel, know how the fuel is prepared for use in a diesel engine, be aware of the purpose of some of the fuel additives that are available. In the previous chapters of this module, we have concentrated on the storage of fuel on board and the procedures and systems in place to achieve this safely with a minimum risk to the environment. The condition of the fuel is, however, unfit for use without further cleaning and pre-treatment. In this chapter, we will look at the way in which we can prepare the fuel ready for use in a diesel engine fuel system. The extent of the treatment really depends on the grade of fuel that we are operating with. Distillate fuels require far less treatment than residual fuels. The main purpose of the settling tank is to give time for any water or solids contained in the fuel to settle to the bottom of the tank. The tank is provided with a drain cock, which should be operated regularly to remove as much of the settled water and dirt as possible. This settling or separation occurs due to the fact that the water and dirt have a higher density than the fuel oil, and over time, gravitational forces will cause these heavier components to pass to the bottom of the tank. This is a fairly slow process, and even with the assistance of heating, which increases the density difference between oil and water, only the larger droplets of water and heaviest solid particles will settle in the time available. As we will see later, we need to use other means to remove the remaining water and dirt from the fuel before we can use it. The settling tank is usually provided with two suction connections for the pumps that take the fuel from the tank. A low suction near the bottom of the tank, and a high suction positioned just above. The valves used for these suction connections will be remotely operated quick closing valves. We have already said that the settling tank relies on a difference in density for the separation to occur due to the effect of gravity. However, this is not the whole story. All matter is affected by gravity. An object will fall to the earth due to gravitational forces acting on it, which is determined by the object's mass and the acceleration due to gravity. The air resistance results in a drag force, which acts to slow down the rate of fall. The difference between the two forces determines the speed at which the object will fall. Similarly, in the settling tank, and ignoring buoyancy forces, the water droplets and dirt particles are subject to a falling force, and the fuel oil provides the drag force. The size of the drag force is determined by the viscosity and density of the fuel and the surface area of the particle. At increased temperature, the density and viscosity of the fuel oil decreases, and therefore the drag force reduces. The settling tank low suction connection will be used for normal operation. If there is a build-up of dirt in the bottom of the tank, or if vessel movement in rough weather is likely to disturb the settled dirt and water, then the high suction can be used. This will reduce the amount of dirt and water drawn from the tank by the pump. A suction strainer is fitted between the tank outlet valves and the pump inlet to protect the pump from damage by the larger particles of dirt. The suction strainer usually has a coarse mesh to help ensure an acceptable flow to the pump. Only relatively large particles of dirt are removed at this stage. Further cleaning of the fuel is necessary before it can be transferred to the service tank for use in a diesel engine fuel system. This can be achieved dynamically using centrifuges or by using a static filter module. Both of these devices are usually self-cleaning. You will probably have one or other of these fitted on your current vessel. We have seen that a settling tank relies on a difference in density to separate different liquids and solids. This is a slow process due to the fact that there is not much difference in the densities of fuel and water, and so the separating forces are relatively small. To speed up the process, The separating forces need to be increased, and this is the purpose of the centrifuge. The centrifuge usually consists of a gear-driven bowl contained within a casing provided with suitable inlet and outlet passages. There is only time for a brief description of the operating principles of the centrifuge in this module. A more complete coverage is given in Seagull's ALCAP series of modules. The high-speed rotation of the centrifuge bowl generates forces many times greater than gravitational force due to the centrifugal effect. This increases the separating force between the different components of the mixture passing through the bowl. The heavy components of the dirty fuel mixture, usually solids and water, move to the outer part of the centrifuge bowl. A compact stack of conical discs are used to assist the separating process. The centrifuge can be set up to allow discharge of water and dirt or to collect dirt in the outer part of the bowl. Most centrifuges are designed as self-cleaning units and have an automatic, timed sludging facility. Click on the buttons to learn about the different arrangements. When a centrifuge is set up to continuously discharge water, it is referred to as a purifier. Dirty oil enters the bowl through a central tube and passes down to the distribution plate at the bottom, and then upwards through the disc stack. The forces generated by the high speed of rotation cause the water and dirt, which are heavier than the oil, to move to the outer part of the disc stack and bowl. The water and dirt gather in a region between the wall of the bowl and just inside the edge of the disc stack. The clean oil gathers in the region from the center of the bowl to just inside the edge of the disc stack. The point where the separated oil and water meet is referred to as the interface. The position of the interface is controlled by using gravity discs with different size central holes or gravity plugs of different length. These determine the effective position of the water outlet. The clean oil passes up the outside of the central tube to the outlet to the service tank. The water flows over the disc stack cover plate to the edge of the gravity disc or plug and out through the water outlet. When a centrifuge is set up without a continuous water discharge, it is referred to as a clarifier. The general operating principles are the same as for a purifier, except that the water outlet is blanked off by the top cover of the disc stack. Instead of separating water and solids from the dirty oil, a clarifier separates solids from a liquid mixture. The solids build up on the inner wall of the bowl and have to be removed regularly. As already stated, this is achieved through an automatic sludging cycle. The factors which affect the performance of the centrifuge are the density difference, the speed of rotation, and the time that the mixture is in the bowl. We usually operate with temperatures as high as possible, but below the boiling point of water to maximize the density difference. Where the capacity of the centrifuges is much greater than the consumption rate of the machinery, then a low flow rate can be used to increase time in the bowl. This also allows us to use two centrifuges in series, one as a purifier and one as a clarifier, which increases the cleaning effect. This is the preferred arrangement where possible. Where capacities of the centrifuges are not much greater than the consumption rate of the machinery, it is possible to use them as purifiers operating in parallel. This allows us to have a reduced flow rate through each centrifuge, but still maintain an overall throughput greater than the consumption rate. When the fuel density is too close to that of water, it is not possible to operate a conventional purifier arrangement. There are a number of centrifuges on the market, designed to operate as a form of clarifier for treating fuel oils with a density of up to approximately 1010 kilograms per cubic meter at 15 degrees Celsius. During normal operation, if sufficient water separates and collects in the bowl, some will carry over to the clean oil outlet, which is fitted with a water sensor. When water is detected, a solenoid valve opens in the water outlet, allowing a short discharge of water to occur before closing again. We have already mentioned the use of suction strainers to protect transfer and feed pumps from relatively large pieces of solid contaminants from storage and settling tanks. We also need other strainers, often referred to as filters, in different parts of the fuel system to ensure the fuel is clean enough to use and to prevent components from being damaged. The majority of filters used in the fuel system will be some form of metal mesh basket or candle type if they are reusable, and paper or felt types if disposable. Click on the buttons to find out more about the different types of filters and the reason for having them. There are a number of alternative fuel treatment methods that we should consider. Some of these may be used instead of centrifuges, although in many cases they are used in addition to centrifuges. Some of the leading marine diesel engine manufacturers state that centrifuging is always necessary to achieve the required cleanliness of the fuel. Mechanical homogenizers can be used to break down and disperse contaminants and heavy hydrocarbons evenly throughout the fuel. Most mechanical homogenizers use either grinding or crushing action to achieve this. They are capable of breaking up solids, emulsifying any water present, and breaking up heavy hydrocarbon molecules into smaller structures. These smaller hydrocarbon structures are easier to burn, so combustion is improved and harmful emissions may be reduced. Using a homogenizer should also reduce the amount of sludge produced, so reducing disposal costs. A type which is available today consists of a conical rotor and stator which have slightly different tapers, so that the clearance is greater at one end than the other. The dirty fuel enters at the end with the greatest clearance, and accelerates through to the exit end, which has the smallest clearance. You may come across homogenizers fitted in the system on board some of your vessels, usually working alongside centrifuges. Many mechanical homogenizers also generate ultrasonic energy, which assists in the breakdown of some of the contaminants, as well as the heavy hydrocarbons. There are also some devices which rely only on the ultrasonic energy to achieve the breakdown. The ultrasonic energy, which is a form of sound energy, causes the components within the fuel to vibrate rapidly, which results in them breaking down into smaller particles and molecules. You may have come across similar lower energy devices which are used for cleaning components by shaking the dirt from them. Cleaning of heat exchanger plates can be achieved this way. There are a number of static filter modules available which can be used in place of centrifuges for fuel treatment. The modules are made up of a number of different filters, typically coarse filter for removal of large solid particles, coalescer filter for removal of water, fine filter for removal of smaller particles, and magnetic filter for removal of some iron-based metal particles. These units are more common for service in either distillate fuel systems or lubricating oil systems. It is unlikely that you will find them used with heavy fuel systems unless there are centrifuges also fitted. Many of the static filter systems, just like centrifuges, are provided with a self-cleaning facility to reduce downtime and manual effort. Whereas centrifuges use sludging cycles to remove accumulated dirt from the bowl at regular intervals, static filter units usually use backflushing to remove collected dirt. Through a suitable arrangement of control valves, the clean fuel is made to flow back through the filter to a drain sump. This flushes the trapped dirt out of the filter elements. A clean filter will be in line while backflushing of a dirty filter occurs to maintain supply. Water is drained from the coalescer unit by a float-controlled drain valve or other similar arrangement. The treatment we have looked at up to now has been pre-treatment required to clean the fuel. At this point, the clean fuel is delivered to the daily service tank, from where it can be drawn for use in the machinery. If the cleaning process has been effective, there should be very little dirt or contamination in the service tank. Regular draining of the tank is still necessary to remove any carryover or condensation. This should be one of your routine duties. We mentioned in an earlier section the problem of microbial contamination of fuel, and said we would look at how to deal with it later. The condition requires the use of chemical treatment in the form of a biocide. Biocides and other chemical additives are widely available to deal with this and other fuel-related problems. Some of these treatments can be added at the storage stage, but most are designed for use in and after the service tank. We are not going to look at the chemistry of the additives here. That would be of no benefit to you. We will look at what the additives are claimed to do. Remember, as with all chemicals, you must take care and use appropriate personal protective equipment as indicated on the material safety data sheets when you are handling them. You can learn more about these by clicking on the buttons. It is generally accepted that if there is no water present in a fuel tank, there can be no microbial activity. You should therefore make sure that water is drained from fuel tanks regularly. Watch out for the smell of rotten eggs, hydrogen sulfide gas from the tanks, which will give some indication of the problem. When microbial contamination does occur, you will need to use biocides to kill off and control recurrence of the bacterial colonies. There are many different biocides available, and most are about 90% effective, so repeat treatment is usually necessary. The treatment can cause problems as the dead bacteria fall to the bottom of the tank, forming a sludge which can be carried into the system, causing further blockage and corrosion. To prevent recurrence of microbes, it is necessary to completely sterilize the system, including all tanks, pipework and fittings. As this is not usually possible on an operational ship, it is best to avoid the problem altogether. Keep checking for water in those fuel tanks. When fuels are in storage, oxidation occurs, which can result in chemical changes to the fuel, leading to sludge formation. The chemical changes can also affect the combustion performance of the fuel. Fuel stabilizers are intended to preserve the condition of the fuel by stopping or slowing down the aging process. If the stabilizer is effective, then the fuel should burn more cleanly and emissions should be reduced. Fuel additives are chemical compounds which are intended to either enhance the performance properties of the fuel or provide properties which the fuel naturally lacks. There are many additives on the marketplace which all claim to achieve these purposes. Some of the most common types of additive are combustion improvers, ignition improvers, detergents, cold temperature gelling preventers, and lubricity agents for low sulfur diesels. Some of the additives have proven to be beneficial, while others may not do all that is claimed. Other treatments which you should be aware of include inline blending and emulsification processes. With blending, two different grades of fuel, usually a residual and a distillate, are mixed together in the supply line to the engine to produce a blended fuel which is better suited for use in the engine than the individual grades. It is possible to vary the blend ratio to suit operating conditions, for example different engine loads, to give optimum performance. Some engine manufacturers have moved to emulsified fuels, a fuel and water mixture, as a way of reducing the level of emissions. This is normally carried out in part of the engine fuel system after the service tank. It may seem strange to you, after all we have said about not mixing fuels and removing water from the fuel, to see that some engine manufacturers are intentionally doing the opposite. When the fuel is drawn from the service tank, further treatment is necessary to make sure that the condition of the fuel is correct for the intended use. Fuel for a diesel engine, for example, has to be heated to ensure that the viscosity is correct for injection. We saw in the previous section that inline blending and fuel emulsification are also used, normally after the service tank. This further treatment is part of the in-use system and is covered in the module on fuel systems, Seagull CBT number 9. In this section we have looked at the various treatment processes that are used when dealing with fuel on board the ship. Some of the processes will be in use on board your current vessel, and hopefully you will now have a better understanding of them. You should also now be aware of other treatments, mechanical and chemical, that are available, which you may come across in the future.